So LCD is reconnected. You can see that it is working like a charm. See, it is moving the text LM from left to right. See, it moves from left to right, and then it do not goes to the end. Why it do not goes to this? Because we have set it to 12 times. Like we shifted it 12 times to the right and 12 to the left. So this is the first column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like you can see those boxes for both the LCD. Even if you have a 16 cross 1 LCD, that will also work over here. So this is it, guys. We'll see you in the next video. Until then. Hello guys, welcome to learning microcontrollers. In this video I will show you how you can interface a PIC16F877A microcontroller with a 24 cross JHD204A LCD. I will show you in this tutorial, this is the third video in this series, that how you can move the text left and right. So let's get started. So guys, this over here is our JHD24 cross LCD. You can see two ports here. They are just a duplicate of each other. Either you use this port, either you use this port. It's up to you. Now guys, this over here is our PIC16F877A microcontroller having 40 pins. It's a DIP version. This over here is a JHD24 cross LCD. We will only use the top connector. So guys, this over here is a 3-pin potentiometer. This is used to adjust the contrast of this LCD, but usually you do not need this, but I will still connect it. So there you can see the potentiometer has 3 pin labeled on its body as well. This is pin 1, 2 and 3 like this. Then guys, these are the 16 pins of your LCD, and if you hold it like this, this is the top connector. From left to right it is 1 to 16. Now guys, let's do the wiring. You common the pin number 1 and 5 of your LCD, then you connect it to the pin number 1 of your potentiometer, then you send it to the common ground of the PIC like this. In this way, your LCD gets grounded and the potentiometer gets the ground. Now guys, pin number 2 of your LCD is the power pin. Now this either you connect to the 5 volt of your PIC, because it only requires a very small amount of current to operate. So you can just power it up from the PIC's power source if it is also working at 5 volt. You connect it to the pin number 3 of your potentiometer, then you connect it to the VCC of your PIC16F877A. In this way, your potentiometer gets the 5 volt, your LCD gets the 5 volt, also your PIC gets the 5 volt from whatever source you are powering it up. Now guys, pin number 3 is a contrast adjustment pin of your LCD. You connect it to the adjustable pin of your potentiometer, that is pin number 2 like this. Now pin number 4 is the RS pin. You may connect it to any available digital input output pin. I'm going to use a pin number D1. For the pin number 6 enable, I'm going to use a D0. For pin number 14, that is the data pin 7 of your LCD, I'm going to use a pin number D7. For 13, D6. For 12, D5. For 11, D4. Now guys, pin number 15 and 16 are for your LCD backlight. This LCD do have a backlight, so connect the pin number 15 to the VDD, and that is our pin number 2. Just common them. So this gets 5 volt from the same source from which your potentiometer and your LCD is getting the 5 volt. And 16 is the ground for the LCD backlight. If you do not connect pin number 15 and 16, still your LCD is gonna work, but you will not see the light at the back, so it will be difficult to see. Now these 4 pins, pin number 7, 8, 9 and 10, they are the data pin 0, 1, 2, 3. They are required if we use this LCD in the 8-bit mode, but in our case we are using the 4-bit mode, so these 4 pins are not required. Just leave them as it is. So this is our total connection, guys. So now let me introduce you to the hardware, then we move on to the programming. So guys, this over here is our hardware. You can see here we have our kit for the PIC16F877A microcontroller with an LCD support. There we have our LCD, and you can see the PIC3 is connected. So this is simple hardware that we have over here. So let's get to the programming. So guys, this over here is our MikroC. I have a lecture on this, how to download and install the latest version from the official website. So you can go check it out. Click on File, New Project. This is the new project wizard. Click on Next, write the name of the project. We have LM204 text moving tutorial by learning microcontrollers. So this is the name I wrote. Select the path where you want the files to be created. Select the microcontroller you are going to use. I'm going to use a PIC16F877A, and the crystal I have at the pin number 13 and 14 is 16 megahertz. Now click on Next and finish. So guys, this window pops up. First of all, before you do anything else, save your work. Either you press Ctrl S or you go to the file and click on Save. This window pops up. Just save it. Now guys, first of all, we need to initialize the LCD. So go to the right. Here you have this system libraries, expand it. Here you have this LCD, check mark this, expand it. Here you have this command called LCD I90, double click on it. This window pops up. Here you have these commands, you copy them till here, go back. Now these are the commands to initialize the LCD in 4-bit mode while we are using the 4-bit mode, so that's enough. Now guys, first of all you need to initialize the RS pin. The RS pin that we set, let's go to the presentation and see again. Now what was the RS pin? Now this one is the pin number 4 is the RS pin, and we have set the pin number D1 for this, for the PIC. Now go to your MikroC, you have to write these pins layouts over here. Now let me open the MikroC. Okay, there we go. Now guys, for the RS pinout setting, it has set B4 by default while we have D1, so change it. Now if you have different pinouts, like you have selected different pins on the hardware, then you just change these, that's all you need, rest will remain the same. So RS pin is D1, EN is D0, data pin 7 is D7, data pin 6 I have set to pin number D6, data pin 5 to D5, data pin 4 to D4, like this. Now same, do the same here, that was for the pinout setting, this is for the pin direction. Now RS pin is, do the same as done above, D1, then we have D0, then we have D7, then we have D6, then D5, then D4, like this. So these are our pin initialization commands. Now let's initialize the LCD. Now go to the right, double click on the LCD and INIT again. This window pops up. Here you have this command called LCD and INIT. Copy this command, paste it in the one-time loop like this. Now give some initialization delay, not necessary, but I always suggest you give it in the one-time loop like this. Just a delay of 250 milliseconds will be fine. So this command will initialize the LCD with following pin settings, and this is the 4-bit mode. We are only using D7 to D4. If it is 8-bit, just you need to add 4 more pins here, D0, D1, D2 and D3. Rest will remain the same. Now guys, we got our LCD initialized. Now I write here while 1, the forever loop. Forever loop starts here and ends here like this. Now guys, in the forever loop, first of all go to the right, there you have this command called LCD CMD. This is a command to do various tasks. Now you copy it, here you have the command, here you have the available command list. Each command does a unique purpose, like this command will move the cursor to the first row, this will move to the second, third, fourth and so on. This will clear the screen, LCD CMD clear if you use this. Okay, let's clear the screen first. So as soon as the code starts, it will clear the screen using this command like this. Now we write our text, whatever the text you want to write, we can write it here. So first of all, what I want to write here, I write like what I want to write here. Okay, we clear the screen in the one-time loop like this. So as soon as the code starts, the screen is already cleared, instead of clearing every time the code execute, because it will add a flicker. Now first of all, we write a command here what we want to move. So we write a small text. So go to the right, here you have this command called LCD out, double click on it, and in the example here you have this command syntax. Copy this command syntax like this, go back, paste it. LCD out, what you want to write here? Okay, we write something like LM, learning microcontroller. So this is our text, and it will be by default at the first row, first column like this. Now what we want to do is that we want to move it. Now to move it, we need a command, this command. So go to the right, here LCD CMD, this window command, this is the example. In the example you have this command LCD CMD LCD clear. This is the command to clear the screen, but we want to move the text. So instead of clearing the screen inside it, you go to the right, you will change the parameter. Now in the table, look for the command to move the text. So what blink cursor, LCD blink cursor on, so it is to turn the cursor on and off. So underline, okay, move cursor left, move cursor right, LCD turn on, shift left. Okay, this is the command LCD shift left. You can use both. You can also shift the text. You can also, this is like scrolling, and you can also move the cursor as well, like you write something and then you tell the cursor to write again and keep on shifting. So we use this one to shift, we just shift the text. So I write shift text right because we are starting from the left side. So we have 20 characters, so we can shift right to the 20. So with the first shift, it will move to the second column, the third and so on. So we shift the cursor to the right, text to the right, and I give a delay here. Like after shifting, it will stay there for like 250 milliseconds, and after that it again shifts. See, now we keep on shifting until we do not reach the end like this. Or you may use a loop here, but if I use a loop here, it will be difficult to understand. You can later on convert it to a loop. So this will shift 2 times, then we like shift, just copy paste the command. Now 4 times shifted to the right. Now it's 1, 2, 3, 4, 5, 6 times. We copy, double it, and it is now 12 times shifted to the right. Like it will start from the first row and first column, then it will keep on shifting 12 times, and then it stops. And after that we shift it to the left, back to the left. So for that, go to the right. In the LCD CMD, you have this command, shift LCD shift left. For this, first copy this syntax, LCD CMD, LCD clear. This is to clear the screen. Again, remove the inside the clear LCD clear part because we want to shift the text. So go to the right, LCD CMD. Here in the table, you have this command called LCD shift left. You have to paste it inside the brackets. That is how this syntax works, like this. Now this will shift the text to the left, and then it shifts to the left, and then it stays there for 250 milliseconds. Then we shift it back to the original state by shifting 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's 11 or 12. Okay, let me check. Okay, there, shift left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, it's 12 times. So that's it. This is the code. We build the code. What we want this code to do is that this text is moved to the right, and then it's moved to the left. That's all we want this code to do. Okay, so this is it. Now after this, we may clear the screen as well. So let's clear the screen as well. If there are any rack-backed values, use this command, LCD clear, LCD CMD, LCD clear. So after this, it will clear the screen, and then the screen will remain clear for like 250 milliseconds. After that, the whole code will start again. So that's all we have here. Now build the code. Okay, it's built successfully without error. Open your PIC16 programmer tool to run the code. Wait for the PIC16 programmer tool to turn on. Here you go. I also have a lecture on this, how to download and install and use this tool. You can go through that. Now select the microcontroller first. PIC16F877A is the one I'm using over here. This one. Click on File. Click on Import Hex file. This is the file we just created. Click on Write. Okay, the new file is being written. Let's wait. First it erases the device, and then okay, there it's an error because I have already have the LCD connected. So sometimes it happens that it's better practice to remove the LCD once while you are programming, because LCD draws power and that causes the programming to fail. So it's better that you remove the LCD during the programming phase like this. So that's a better practice. So let's do this again. Okay, I zoom in. Just import hex file. Click on write. Okay, let it write. Wait. Okay, it is programming the device. See, no error this time because this time I have removed the LCD, because sometimes it happens that you have to remove the LCD else there are errors. So once it's programmed, I will reconnect the LCD. So we may reconnect the LCD right now. So LCD is reconnected. You can see that it is working like a charm. See? It is moving the text LM from left to right. See, it moves from left to right, and then it do not goes to the end. Why do not goes to this? Because we have set it to 12 times. Like we shifted it 12 times to the right and 12 to the left. So this is the first column, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like you can see those boxes when you see it from an angle, they are your columns, and these are the 4 rows, and these are the 20 columns. So we are only going till 12. So you can see that it is working like a charm. So guys, this is it. If you guys have any questions, you may ask, and I will give you the codes in the description so you can like play with the code and learn better. So we'll see you in the next video. Goodbye until then. And let me tell you another thing, like this LCD, and let me replace it, this LCD, they have exactly the same pin out. So this is your normal one, just connect it the same way over here. They have same programming, same pin out, same library. So this will work the same over there. Just you have to adjust the contrast using the contrast adjustment resistor. This resistor over here, you just readjust the contrast for this LCD. That's all you need to do. See, now let's just reset the code so it will work. Just turn it off, turn the power on. Now see, the same thing is working here as well. This is 16 cross 2, so still it will work because we are in the limit of 16 characters. So adjust the contrast. That's all you need to do when you change an LCD. See, the contrast is now fine. See, the code is exactly the same for both the LCD. Even if you have a 16 cross 1 LCD, that will also work over here. So this is it, guys. We'll see you in the next video. Until then.